and participants. Bharati Vidyapeeth Institute of Computer Applications and Management BVICAM in association with Computational Intelligence Society CIS chapter of IEEE Delhi section, Computer Society CS chapter of IEEE Delhi section, Technology and Engineering Management Society TEMS chapter of IEEE Delhi section, System Man and Cybernetics SMC Society chapter of IEEE Delhi section, Communication Society of IEEE Delhi section, Consultants Network Affinity CNA Group of IEEE Delhi section, Life Member Affinity LMA Group of IEEE Delhi section, Inter-Society Relations IRS Standing Committee of IEEE Delhi section, Industry Relation and Special Interest Group on Humanitarian Technology, Site Standing Committee of IEEE Delhi section, Region 10 of IEEE with the Associations of Computer Society of India, Institute of Information Technology Professionals IITP, ISTE Delhi section, and IETE Delhi Center as technical collaborators. Welcome you all to the IEEE IETE BVICAM technical lecture series on neurotechnology enabling human augmentation. According to Matt Hicks, neuroscience is a baby science, a mere century old, and our scientific understanding of the brain is nowhere near where we did like it. We know more about the moons of Jupiter than what is inside our skull. This quote is an indication of the challenges that neurotechnology faces in this digitized era today, where we have machines competing our brains in every domain. Neurotechnology refers to a field of technology that involves the application of principles and techniques from neuroscience to develop technologies that interact with or manipulate with the nervous system. It encompasses a wide range of devices and tools and techniques that interface with the brain or nervous system for various purposes, including medical, research, and consumer applications. Neurotechnology is enabling efforts towards human brain and augmentation. This webinar today will discuss its all around perspective, including the real time issues and challenges. I would first take this opportunity today to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would first welcome amongst us Professor M. N. Huda Sir, Director, Bharati Vidyapeeth Institute of Computer Applications and Management, BVICAM, and Executive Vice Chairperson, IEEE Delhi Section, to address the participants with his inspiring words.
Good evening, one and all. Am I audible, Dr. Ritika?
Yes, sir.
I have kept video off because traveling in the car, so signal is low. Good evening, one and all. At the outset, let me take this opportunity to welcome my valued speaker today, Mr. Rahul. We are close friends since long, and then I came to know we are having a common friend, Mr. Ajay, as well. So, welcome, Mr. Rahul, on this platform. This platform is one of the niche platform of entire world, known as IEEE, IETE, CSI, BVICAM, weekly, evening, Saturday webinar series. And the topic for today's webinar is Neurotechnology Enabling Human Augmentation. And this is 144th of episode of this webinar series, which we are running since May 2020 in the backdrop of COVID-19. Dear friends, you will be happy to note that this webinar series, after adjudication by IEEE USA, has been adjudicated as the most sustainable webinar series in entire world, which was started in the backdrop of COVID and still being continued without any break. So this credit goes to my entire team and the people who from different parts of the country and abroad keep on joining for this webinar. Thank you so much. I also take this opportunity to welcome all my friends from various professional societies. Mr. Ajay, my friends, the chairperson of industry relations. I know this last 2 weeks has been very hectic and over-occupied for him, yet he is here. And Professor Subramaniam, who probably has not missed any of our webinars since May 2020. So they need very special appreciation, and I'm grateful to them. And above all, the participants from entire world, webinars, depending on the topic, they keep on waiting and they keep on joining. I'm grateful to all of you. Dear friends, the topic that neurotechnology enabling human augmentation is the future. And Dr. Ritika has very well introduced this topic, and we are here to understand that what at the new dimension, what are the present state of art. Mr. Rahul is going to enlighten us and make all of us know. We have been talking about virtual reality. We have been talking about augmented reality. We have been talking about augmenting our capabilities, but now we are talking about augmenting the humans and how to ensure that what neurotechnology is made for a natural or because of the nature, how can we include or we integrate or embed the similar features in our system so that the system should perform better and better. So thank you so much. Wish you all the best. Other webinars have already been notified. If you have not registered for them, please do register for those webinars, because if you members, that keeps us motivating our entire team, and we will be back with all of you. Nowadays, instead of every Saturday, we are organizing it on alternate Saturdays. So every alternate Saturday with one or other topic, we are here. So keep joining, keep learning despite disruptions. Stay safe, stay healthy, stay vibrant, and keep sharing our information with your friends, with your colleagues. Dr. Ritika has already informed you that we have a YouTube channel where the recording of all these webinars as a huge repository is available. So utilize the facilities, utilize the advantage of that. Thank you so much. Wish you all the best. God bless you all. Over to you, Dr. Ritika.
Thank you, sir. With this, I shall first now welcome amongst us our expert, Mr. Rahul Agarwal, sir, with an e-bouquet.
Thank you.
Sir is an experienced engineering leader with extensive experience in communication product engineering. Sir has a proven track record of managing engineering deliveries of very large teams, 500 plus for global customers spread over Europe, US, and APAC. His significant contributions have been in the areas of building long-sustained engagements with Tier 1 OEMs from zero to over 80 million US dollars. It has a strong engineering professional who has led programs in diverse technology areas, including the wireless, LTE, WCDMA, GSM, GPRS, Wi-Fi, cloud, datacom, satellite, telecom, etc. Currently leading 3SR Technology organization, he has a wide drive for transformation of projects from DevOps to mode of delivery. We are honored to have you amongst us, sir, today. I would now request you to kindly enlighten the House. Sir, you are on mute.
Thank you, Dr. Ritika, for the warm welcome. And it's an honor to be with all of you and talking about a very, very pertinent topic that relates to neuroscience and neurotechnology, which basically pertains to humans. So I like to take it through some presentation. So I'll just. Is it visible now?
Yes, sir.
Okay. So we are talking about brain, and as we know, like so brain is central command of the body, and it controls all the body actions. It handles emotions. It takes care of cognitive functions. So effectively, the whole body is under control of brain. And neuroscience is the study of brain, but somehow we have been mostly associating neuroscience with medical field. But if you look at the study of neuroscience can be beneficial in all walks of life, and that's what uh, the focus has changed now. People are talking about using neuroscience in different fields, uh, right from education to leadership, management, uh, from enhancing humans. So that's what we are going to talk about today. So recently there was a news item that came on 30th of January, where it was indicated that Elon Musk says that his startup Neuralink has implanted a device in its first human. So the question comes, what's the purpose of this? And as per Neuralink, they are looking for, they're calling this product as telepathy, and they want to ultimately achieve uh, something through which people can control their phones just by thinking. So Neuralink is not the first company who has done this kind of implantation in the brain of a human. In fact, this kind of implantations and the studies related to that has been going on for more than a decade, and scientists and researchers have been trying to help people with the neurological disorders to circumvent their disabilities. So the Neuralink also aims to make these devices to treat serious brain diseases, but their eventual goal is human enhancement through brain augmentation. So what is brain augmentation? Brain augmentation essentially is enhancing the capabilities of brain through use of technology. But the question is, why we need to augment brain? So aren't we trying to emulate brain through artificial intelligence? After all, we have been considering to make our computers act like our brain. So if we analyze further, then we realize that computers make us feel the brain's limits. So brain also has certain limits. So we know that speed of information processing or calculations is much faster when it is done by computers. Or if you look at the sharing of thoughts and experiences, these are something which, uh, if we talk about humans, their learnings are limited to the person. But if you look at the computer, the learnings of a computer or the memory can be put on a cloud or via some other means. It can be shared across very easily. If you look about memory storage, we have a tendency to forget. As humans, we tend to forget certain things, but computers have a kind of a very robust memory. Similarly, learning new skills, if we look at the humans, we need to do a lot of practice. But when we look at the computers, it is just like loading a new program, and the computer can start performing as per that functionality. Also, if you look at the information loss in communication, so the way we have limitations in terms of our communication, many times the information gets lost, and many times it gets altered while it gets communicated. But computers have a very robust communication mechanism which has been developed via different mechanisms. And also, if you look at brain gets its inputs via different sensory organs, but uh, it is limited by the capacity of those organs. So we have a limitation in terms of what we can hear, what we can see, what we can smell, and so on. But we know that with computers, we can have different types of devices. We can change input devices, and we can process much more signals. So These are some of the things which get highlighted when we make comparison between our brain and the computers. So the question comes, can we enhance the capabilities of a brain by combining the capabilities of computer? And that's what we are talking about, uh, brain augmentation, and ultimately that brain augmentation will lead to human augmentation. So imagine there is a hotel where your favorite dish gets served the moment you start craving for it, or you can control your computer's mouse with your brain instead of your hand. You think about moving your cursor and it just moves. Or you forgot your where you left your keys, and uh, then you rewind your memory to find where you had last seen those keys. Or you think of a patient with a spinal cord injury, and he can walk again by uh, certain treatment. So these scenarios sound like science fiction, but these are just some of the countless applications that neurotechnology will enable in coming decades. So what is neurotechnology? It's a technology which enables brain augmentation. It's an integration of technical components, sensors, electronic devices with the nervous system. And that's how
Rahul,
it's
your
like.
voice is breaking. I don't know at my end.
Uh, okay. Is it being experienced by everyone?
Sir, it is breaking still. Rahul sir, you are on mute now.
Uh, am I audible now?
You are still breaking, Rahul.
I think I have to back once again.
Rahul, you may have to log out and log in again if.
Dear participants, Rahul sir is there with us, but due to the technical glitch, we are trying to resolve the technical glitch, and he shall continue with his session. Thank you, dear participants.
Yeah, I've spoken to Rahul, so he's just joining again.
Yes, sir. So, dear participants, due to a technical glitch, there is a brief, I would say, break. Rahul sir is joining us again. Please stay with us meanwhile. I think sir has already started wonderfully by explaining and drawing comparisons between the human brain as well as the computing machines. Ma'am, sir is with us in panelist. Please promote in attendees. Please promote him to panelist. Rahul sir has joined us back. Rahul sir, now you can unmute yourself.
Am I audible now?
Yes, sir.
Okay. I really don't know what happened, but somehow the system got hanged.
Yes, sir.
Sorry about that. So is my voice clear now?
Yes,
Not
sir. The
very
voice
much.
is clear.
Yes, sir.
There is a video lag.
Okay. Is my presentation visible?
Yes, sir.
Yes, sir.
Okay. So we were talking about what is neurotechnology. So this is a technology enabling brain augmentation. It integrates technical components like sensors, electronic devices, etc., with the nervous system. Methods. It includes methods and devices which interface with the brain to monitor or modulate the neural activity. It includes technologies which enable visualization of brain processes and also control, repair, or improve its functions. So what are the objectives? Uh, so there are three objectives, and the objective one is to read the neural activity, which means understand what is happening in the brain, which will help us in understanding the emotions which the brain is experiencing. And if we are able to do that, it throws a huge possibilities that what kind of emotions a person is experiencing. Similarly, it will help us in understanding what kind of motor controls the brain wants to apply on the body. So as we uh, talked about in the beginning, that brain controls the body parts. And if we can understand what control the brain wants to apply on the body part, that can help us in helping patients which are paralytic. So who are not able to move their limbs using using brain commands. So we can help them by artificial limbs by controlling their mind. The objective two is to manipulate the neural activity. That means that you can enhance or diminish something happening in the brain. So brain is a very complex organ, and it has a lot of internal processes, and any kind of enhancement or diminishing in the activities uh, among the different components of the brain can lead to some kind of neural disorders. So if we can manipulate those neural activities through neurotechnology, that can be a huge help in medical field. So like treating the Parkinson's disease using the technique called deep brain stimulation, or use of ultrasound to treating the tremors. So these are just some examples where uh, manipulating the neural activity, the neural disorders can be addressed. And the third objective is augmenting the cognitive abilities. So we have already seen some kind of artificial limbs like bionic eye or cochlear implants, which help us uh, in having a artificial eye or ear. Uh, so these kind of artificial limbs are already becoming a reality. Uh, these implanted devices in future can also make us smarter, or they can improve our memory or help us in decision making. And eventually it can provide an extension of the human mind, a concept which is called as human augmentation or transhumanism. So if you look at the nervous system, it is comprising of brain and the spinal cord. So we have a brain and the spinal cord, and there are different nerves which are spread across the whole body. And the brain is connected to these different parts of the body through these nerves, and it sends control commands to different parts of the body through these nerves. So if so for example, you want to lift your hand, the brain wants to brain gives a control command to the muscles of the hand, and muscles of the brain lift the hand. Similarly, if the hand experiences uh, something like a hot or so the sensors in the hand pass on that information through these nerves to the brain. So basically, these nerves act as a two-way communication between brain and the rest of the body, and brain acts as a kind of a central controller. So I think all of us are familiar with the computer architecture. So it is like we have these as different input and output devices, and brain is your central controller. Now there comes the concept of action potential. So action potential is something which is uh, allowing communication between neurons. Neurons are basically the basic cells of brain, and our brain is composed of a huge number of neurons. It is estimated it has around 86 billion neurons, and each neuron is estimated to be connected to 10,000 further neurons. So it's a extremely complex system which is sitting on our shoulders. So neurons communicate via electrical impulses, and these impulses are called action potentials. These are actually a small millivolt kind of what electrical voltage. So this is a typical structure of a neuron, and this is basically the main body of the neuron, which is connected to other neurons through this tail-like structure, and this is connected to other neurons via these branches. So there is a chemical reaction which happens within these neurons. So these neurons contain sodium and potassium ions and chlorine ions, and due to chemical reaction, the voltage gets generated, and that voltage gets passed along this neuron. So these electrical impulses are basically the basic communication mechanism, which is uh, which acts as the brain signals, and this brain activity never stops. Even when we are sleeping, this activity of action potentials continues. So neurons create and send more messages than all the phones in the entire world. So you can imagine the kind of activity which happens in our brain. And the amount of electricity generated in our brain is enough to uh, power about a 15-watt electric bulb. You can experience this by mildly hitting your uh, is the sharing stopped, or
Yeah, I can't see the screen, Rahul. You may have to share again, Rahul.
okay?
Yeah, I can see it.
Yes.
Okay. So you can mildly hit your funny bone, and then you experience some kind of electrical current in your hand. That's what is the action potential. So I will just like to show a small video here, which will help you understand how Is audio, are you able to hear?
No, sir, not yet.
And I want to do.
Is it audible now?
Yes, sir.
You guys want to see some? All right. All right. So I need a volunteer. So right before, what is your name? All right, Sam. I'm going to record from your brain. Have you had this before? No. Okay. All right. I need you to stick out your arm for science. Roll up your sleeve a bit. All right. And so what I'm going to do, I'm putting electrodes on your arm, and you're probably wondering, I just said I'm going to record from your brain. What am I doing with your arm? Well, you have about 80 billion neurons inside your brain right now. They're sending electrical messages back and forth and chemical messages. But some of your neurons right here in your motor cortex are going to send messages down when you move your arm like this. It's going to go down across your corpus callosum, down onto your spinal cord, your lower motor neuron, out to your muscles here. And that is electrical discharge. It's going to be picked up by these electrodes right here. And we're going to be able to listen to exactly what your brain is going to be doing. So I'm going to turn this on for a second. Have you ever heard what your brain sounds like? No. All right, let's turn it on. So go ahead. Whenever you go ahead and squeeze your hand. All right, so what you're listening to, so this is your motor units that are happening right here. Okay, so let's take a look at it as well. So I'm going to stand over here. And I'm going to open up our app here. So now I want you to squeeze. Yeah, so right here, these are the motor units that are happening from her spinal cord out to her muscle right here. And as she's doing it, you're seeing the electrical activity that's happening here. We can even click here and try to see one of them. So keep doing it really, really hard. Yeah, so now we've paused on one motor action potential that's happening right now inside of your brain. Okay. Do you guys want to see some more? All right. That's interesting, but let's get it better. Okay, I need one more volunteer. Okay, what is your name, sir? Miguel. Miguel, all right. You're going to stand right here. So Miguel, when you're moving your arm like this, your brain is sending a signal down to your muscles right here. I want you to move your arm as well. All right, so your brain is going to send a signal down to your muscles. And so it turns out that there is a nerve that's right here that runs up here that innervates these three fingers. And it's close enough to the skin that we might be able to stimulate that, so that we can do is copy your brain signal that's going out to your hand and inject it into your hand so that your hand will move when your brain tells your hand to move. And so in a sense, she will take away your free will and you will no longer have any control over this hand, okay? You with me? All right, so I just need to hook you up. All right, so I'm going to find your ulnar nerve, which is probably right around here. You don't know what you're signing up for when you come up and so now I'm going to move away and I'm going to plug it into our human-to-human interface over here. Okay, so Sam, I want you to squeeze your hand again. All right, do it again. All right, perfect. So now I'm going to hook you up over here so that you get the stimulus. It's going to feel a little bit weird at first. This is going to feel like a... You know, when you lose your free will and someone else becomes your agent, it does feel a bit strange. So I want you to relax your hand. All right, and Sam, you're with me? All right, so you're gonna squeeze. I'm not gonna turn it on yet, so go ahead and give it a squeeze. All right. So now, are you ready, Miguel?
Ready as I'll ever be.
Okay, so I've turned it on. So go ahead and turn your hand. Do you feel that a little bit?
No.
Okay, do it again.
Oh, a little bit.
A little bit. Okay, so relax. No, hit it again. Okay. Oh, perfect, perfect. All right, so relax, do it again. All right, so now, all right, so right now, your brain is controlling your arm and it's also controlling his arm. So go ahead and just do it one more time. All right, so that's perfect. So now, what would happen if I took over my control of your hand? And so just relax your hand. What happens? Nothing. Why not? Because the brain has to do it. Now you do it again. All right, that's perfect.
So this video highlights that how the controls, which are control signals which are sent by brain to the hand, are interpreted, and which can be also copied and taken out. The similar thing can be seen in insects as well. So insects also have neurons, and they also have this action potential, and also the plants. So in the interest of time, I'm not playing those videos, but I can share those links separately, and you can see those separately, and then make understand. Moving forward, so we are going to talk about brain waves, and these brain waves is not just something mythical; it is actually a real thing. The neural communication via action potentials, as we discussed, is active all the time, even during sleep. And this flurry of action potentials lead to waves when measured and plotted using appropriate devices. So we can record these action potentials and plot them as a graph. These are called brain waves, and this electric nature of the brain is basically the core of neurotechnology. There are different types of brain waves. The frequency and nature of these brain waves depend on the brain activity at the moment. So what is happening currently in the brain, that determines what is the nature of those brain waves. And there are 5 widely recognized brain waves associated with different brain conditions. And these are different types of brain waves. The gamma waves are basically indicating which are basically 35 hertz, more than 35 hertz of frequency. These indicate a brain condition where it is very, very intense concentration and learning. The beta waves is 12 to 35 hertz, and it is a condition where when the brain is in a problem solving and engaging mode. Alpha waves are 8 to 12 hertz, and this is when you are relaxing and kind of rejuvenating. The theta waves are when you are in a light sleep or dreaming, and finally the delta waves are when you are in a deep sleep or dreamless sleep, or when you are unconscious. So by measuring the type of the wave and plotting them, we can understand what is the current state of the brain. There are different tools which are available to measure the brain waves, the what condition the brain is. One of them is electroencephalogram, which is called EEG, and it's a non-invasive monitoring technique. It basically requires a lot of electrodes, different electrodes to be put on the brain, on the scalp, and these are connected to the monitoring device, and captures brainwaves as wavy lines in the different from different electrodes. So each electrode will provide the action potentials over a period of time, and by analyzing these waves, we can see what is happening in the brain. So EEG is a very powerful tool, and it is being used in different applications.
Rahul, your voice is breaking again.
Better now?
So your voice is breaking a bit.
Am I audible?
Yes, sir, you are audible, but it's breaking a bit.
Okay, I'll try to log in once again.
Yes, sir. Dear participants, we apologize due to a technical glitch. Sir's voice was breaking, but in order to ensure that you can gain complete knowledge of the session, Sir would again log into us. I request participants to please be there with us to understand how neurotechnology is helping us overcome, I would say, many neurogenerative disorders. Parkinson's, sir has already discussed in one of the examples that how Parkinson's disease is being treated with neurogenerative disorders. But I think this neurotechnology as a science has far much more applications than what is currently being unearthed. Because once we completely understand the brain, we completely are able to augment and simulate its power. Um, I don't think any neurogenerative disorder would be difficult to capture. We are sorry for the technical glitch due to which sir's voice was breaking. We are trying to resolve the same. Ma'am, Rahul sir has also joined us in the attendees. If we could.
He's showing me panelist.
Okay, okay. Ma'am, now Rahul sir is in the attendees.
Okay, ma'am.
Rahul sir, you have now been promoted once again.
Is my screen visible now?
Yes, sir.
Okay. Hope our audio is also clear.
Yes, sir.
Okay. So we were talking about EEG, and we talked that there are different monitoring electrodes which help us in capturing the action potentials from different places on the brain. And EEG has a lot of applications, so which are being attempted at. And one of the applications is to use it as a kind of a wearable device to monitor student attention. So I'm talking about some applications which are being done in the education industry. And it's a cap-like EEG device, so it doesn't require that we have to put electrodes directly on the skull, but you have a kind of a helmet kind of or headgear, which can be put on students' head, and it has small sensors to get the real-time data, and it observes which portion of the brain are active during a lecture and determine whether students are concentration during that lecture. So this can help in designing your programs and seeing what kind of engagement we have with the students. So this is something which is being tried in different countries, including China. And there are multiple companies who are offering EEG devices like Emotive, Neurosky, OpenBCI, and others. So these are devices uh, which are being looked at for different applications. So another application is EEG-based learning environment, where it's the learning environment supports learners based on their speed of learning, and this can capture the neuro data like how a student is feeling when it is presented with different questions. So if it is finding it them challenging, then you can look at adapting your next question. So this is in contrast to adaptive learning, where you present the next question based upon what the response of the student was. But here we are trying to see the kind of difficulty being faced by or felt by the student. So fMRI is another technology which is functional MRI, or it's basically the MRI applied for scanning brain. So it's a non-invasive brain imaging technology which detects brain activity by measuring the changes in the blood flow, and it can reveal which part of the brain is active during specific functions, such as lifting your arm or even just thinking about something. So what kind of uh, actions or what kind of uh, blood flow is happening in your brain, which part of the brain, that can help in research uh, and to the physicians. It can even potentially allow you to see your thoughts and feelings, and these are also being used to see what kind of image a person may be thinking about. So there are a lot of research which is happening in that area as well. So just by looking at your fMRI scan, uh, people are trying to find what kind of image you may be thinking about. So there are some other non-medical usages of fMRI also, where they are trying to find out the vocational aptitude of a person. So uh, the scientists are trying to see whether the brain structure and how different parts of the brain are connected to each other, that connects with the aptitude of a person. And if that can give us inputs about what kind of career a person can take, or what kind of development needs a person can have, that can be a kind of a huge
Yeah.
help. Is there any question? Okay, so there are other technologies as well, like magnetoencephalography, MEG, NIRS, which is near infrared spectroscopy. But in the interest of time, I'm not going to talk about all of these. I can provide separate links to learn about them. But what I'm trying to highlight is uh, that there are multiple technologies which are being developed to study brain, and EEG and fMRI are definitely among the prominent ones. We are also let's move on to another concept of memory consolidation. So we learn something, and when we sleep, that helps in consolidation. So we make memories every second, every minute, every hour throughout the day. But at the end of the busy day, our brain is completely full, and we find that we are not able to comprehend anymore. So during sleep, a memory consolidation happens that works out what is worth keeping and what is not, and that helps in boring and inconsequential stuff to fade away. So this memory consolidation also works out the links of the new learning with the previous learning. So this helps in a better comprehension of what we are learning that day. So effectively, the sleep helps us in consolidating what we are learning during the day. But if we say like what did we have for breakfast today, probably we can tell. But if I ask this question for a like what did you have for breakfast about a week back, probably will not be able to answer that. So this is basically because our brain keeps on erasing memories which are not very kind of considered to be very useful. So memories stay if there is some spatial moment associated, like novelty, surprise, or we face a terrifying situation, leading to an arousal of emotions. For example, you may still remember what you wore on some specific special occasion. And this emotional arousal helps in preservation of these memories. So this is basically something which helps in preserving memories. So scientists are also looking at how we can achieve this preservation of memories through some external means. And this is a technique called optogenetics, where uh, it's where we are using of light to create the arousal kind of effect using. So it combines the power of light and genetics. And in this, what you do is that optical fiber is inserted in a brain, taken to the area where you have memories, and you expose that brain area to light. So it results into much longer memory. And this is something which is developed at the Stanford University. So it is currently being experimented. So what I'm just trying to highlight that how science is trying to in better in terms of our brain capabilities. The next topic which I want to talk about is the brain-computer interface, or BCI. It's a devices that create a direct communication pathway between brain's electrical activity and an external device. So it's like this, that you have different sensors through which you acquire a signal, and this signal is processed for the features and the pattern, identifying the patterns, and then it is fed to a control. And this control signal is given to a uh, robotic arm, or maybe some other kind of control panel. So these signals could be brain's motor instructions. So if the brain wants to kind of lift your hand, that signal will be acquired and fed into the robotic arm, and that robotic arm will take those actions. So it may look like it is step towards telekinesis. ACI essentially lets a person turn their thoughts into action. That is what telekinesis is. And turning brain signals into commands for a computer system means paralytic patients will be able to move a cursor, type a keyboard, manipulate prosthetic just by using their brain. So that's the kind of power which a BCI can provide. Research have succeeded in making an amputee control his prosthetic hand using just by mind. And BCI implementations range from different from non-invasive to partially invasive to invasive. So depending upon how close the monitoring these monitoring devices go to the brain tissue, that is what defines whether it is invasive, non-invasive, or partially invasive technology. There are different applications which we can have through BCI, like marketing, healthcare, smart environments, in education, security, or gaming. This is a progression how BCI has progressed. So right from 2014, where we have uh, different successes in implementation of BCI, and currently we are able to even decode the words from the thoughts. So of course, the speed is not that high, and there are various reasons for that. We will talk about those challenges, but there is a continuous growth development happening in this field. Who are the major players in BCI domain? MaxMind is one, Neurable, BrainGate, ClearPoint, Neuralink, Synctron, Blacklock Neurotech, and for then BlackRock Neurotech is the oldest one. They have been working in this area for the more than 10 years, and they have the Neuroport array as the chip which they initially introduced, and this is implanted on the surface of the brain, which has a number of electrodes, and it is very proximate to the neuron, and they have already tested it on a number of persons. But there are certain risks like scarring, local damage, and the device rejection. So not every device gets accepted by the body. So these are just some pictures how when it gets implemented. The Stantrode or from Synchron is the second one, which is different from uh, the BlackRock one, where it introduces a electrode array, which is basically goes in a neurovascular way. So it is introduced through the motor cortex, through blood arteries, like what you have a endovascular stent, which is used for heart patients. So just like heart patients get this endovascular stent, the similar way, this synchronous Stantrode is introduced in the brain, where it can help in providing information about the brain signals. So the advantage of this method is it doesn't cause any kind of inflammation, and body is also kind of more acceptable to this. It doesn't require any neurosurgery. And telepathy is the latest one, which Neuralink declared on 30th of January. So it is a fully implantable and cosmetically invisible kind of device. So what you have is a device which is uh, sealed in a biocompatible enclosure, and this whole device is planted inside the brain. It's powered by a small battery, and which can be charged wirelessly, and it records neural activity through multiple threads. And these threads are very thin, and they have also developed a special robot to this kind of to do this kind of a neurosurgery. And they have an external Neuralink application. So this device captures the neural data and sends it to this Neuralink application, and Neuralink application handles and analyzes this data and converts them into different actions. So let's talk about some challenges which ECI technology has. So one is usability, because these these require a lot of training for the users. It also causes fatigue because they need to when they use these devices, it requires a lot of attention, and there is no movement they can do at that time when they are using this device. So it requires a lot of focused training on the part of users. Then there are technical challenges, like when we talk about brain signals, there are a lot of uh, chaotic signals which occur, and it requires a lot of analysis, filtering. Uh, so that is something a big challenge in terms of analyzing the signals, and also that signals are not stationary. So for the same hand movement, the kind of signals which are given once, the next time the signals may be something different. So arriving at a kind of a common signals may be kind of a big challenge. And also there are certain policy issues in terms of ethical framework and the security and privacy. So once you are into a person's brain, so what kind of information you are extracting, or what kind of data you are getting. So that is something is still very unclear. And
So Rahul, your voice is again breaking.
sorry.
We can't hear you.
You are not audible.
Participants, we apologize for the technical glitch. Due to technical difficulty, there has been a bit of break. Dear participants, please stay with us. Sir would be joining us back soon. It's wonderful to be introduced to this power of neurotechnology. How I would say neurotechnology is trying to overcome all challenges and trying to augment the human brain. And this is especially helpful to people with disabilities, especially neurodegenerative disorders and other kind of disabilities. So advances in neurotechnology in some way or the other, they are empowering the mankind as a whole. So it's wonderful to have been known all the applications that neurotechnology is having in the recent times. Any questions any participants have, please write them down in the chat window. At the end of the session, I would be discussing them with Sir. So meanwhile, any questions that you have, please write them down in the chat window. Sir is joining us back again. We apologize for the technical glitch, but technology also has its. Sir is already there with us in the attendees, so we are promoting Sir to panelist. Ma'am, please promote Sir to panelist.
Yes, ma'am.
Ma'am, Rahul Agarwal Sir is there with us in the attendees. Ma'am, Rahul Agarwal Sir is there with us in the attendees. No, no, ma'am, in the attendees. In R, if you see, in R, below Rajpal Singh.
And Ram Krishnan Mitra and Roshan Kumar Yadav.
No, no, after Rajpal Singh, I think Rahul Agarwal Sir is there. Sir is connected with his laptop. एक मिनट।
Yeah, Dr. Ritika, so he's still in attendees.
Yes, sir. We are trying to do the same.
Okay, okay. Rahul,
Rahul,
you
sir,
are there
you are
now.
now the panelist.
Okay.
Sorry for the delay, sir.
Yeah, so I really don't know what's happening with my laptop, or whether it's a link issue.
Sir, I think it's only a bandwidth issue that we have a bit of it.
Okay, so I'll just try to quickly wrap up. I'm just on a couple of last slides. So
No issue, sir.
So apart from the challenges which we discussed, we have a lot of opportunities in terms of helping people with the disabilities. We can augment human capabilities, enhance human to computer interaction. It will facilitate in the brain research. So impact of neurotechnology, the field of neurotechnology, which is still very much in its infancy, can dramatically change the way we do our daily tasks. Say, think about that in a future scenario uh, where you can see things at night by switching your vision to the infrared mode, or hear your music without using headphones, or translate experiences into digital signals that could be transmitted through brain to brain interfaces, or instant learning where you can just like the matrix way, where you can just download a program and learn something new. So accelerating the evolution, experts predict that in 20 to 30 years, brain implants will be just as common and acceptable as cardiac pacemakers are today. And it has potential to completely transform the way we learn and experience. In terms of Mark Zuckerberg, people will one day be able to share full sensory and emotional experiences online, and not just photos and videos. And in terms of Elon Musk, merger of biological intelligence and machine intelligence would be necessary to ensure we stay economically viable. And just quickly want to share that there are multiple Indian startups who are working in this field, in the field of neurotechnology. So it's not just in foreign companies who are working in this. We have a website which is providing neuro learning space. This is called neurolearn.space. You can visit this website and get information about different aspects of neuroscience, not medical, not from medical perspective, but from the other aspects of life. So that's all I wanted to cover, and I'm open to take any questions which participants may have.
Thank you, sir. Thank you for the wonderful session. The simplicity with which you have explained the, I would say, empowerment that neurotechnology is bringing across humans is wonderful. I would now take a few questions with your permission.
Sure.
So the first question we have, neurotechnology would help many people suffering from neurodegenerative disorders, like you have already discussed. But would its access be biased due to the cost involved, or are the costs actually less?
Yeah, so that is definitely a very pertinent question, because currently uh, we have very limited access to this technology, and the development in this area is also very slow. So the first users are basically targeted towards people who have neurological disorders. So currently the research and funding in this area is limited, and the cost is currently not that low. So, but the EEG devices which I mentioned, those are going to be available. Uh, those are available in any spectrum. So you can get EEG devices right from say 20,000 to even few lakhs. So there's a huge spectrum in terms of EEG devices based upon what kind of accuracy they provide. So um, the high technology would be would remain costly at least for some time.
Yes, sir. So next question that we have with a particular author. Is it true that left side brain nervous blockage affects right side organs and vice versa?
Yeah, so the left brain controls the right side of the body, and the right brain controls the left side of the body in terms of the motor controls. But uh, apart from that, there is a kind of a, I would say, neuro myth that some people think only using their left brain or right brain. Probably that is not correct. So when we think about some problem, it requires us to think both from left as well as the right brain.
Yes, sir. So next question we have. What strategies the government is taking to like inculcate and promote neurotechnology and its application? So are there any government controls and motivations?
So in India, uh, the government medical institutes like NIMHANS, ISC Bangalore, and other institutes are have started working on research in this area, but still there's not much clarity about what kind of policy framework is going to be there for this. So as I indicated that there are already some startups who have come up in India also. So in terms of policy framework, the government is right now more focused towards uh, the neuro patients, not uh, not kind of applications beyond that. But we have the government has formed a brain research center which is there in Gurgaon, Manesar, and that is focusing on brain related research.
Yes, sir. So, one last question. Are there any standards in place for all these neurotechnology applications which are being applied to humans?
Standards in terms of protocols, communication protocols or so. So not exactly, because it is still very much dependent upon the research teams uh, and the medical teams, and their efforts are very much kind of happening in pockets. But the governments of different countries like USA, in Japan, China, they have formed some focus research groups, and they are evolving. They are trying to kind of coordinate the research and development efforts in this field. So, not very well established standards right now.
Thank
And
you,
it
sir.
is mostly driven by the uh, medical profession.
Yes,
So,
sir.
the standards which are prevalent in the medical field, those are definitely applicable. So that is there. But in terms of the technology and what kind of protocols it will follow, that is still not very much in place.
Yes, sir. Thank you, sir. Thank you so much. With this, we come to an end to this wonderful session. I would now request Professor M.N. Huda sir to kindly present a certificate to Rahul sir as a commemoration for this wonderful session.